All right, this is the Chapter 2 practice test for extra credit. Now, just to be clear, you're doing it on big ideas to check your answers, but if you don't turn in a work paper for this assignment, you will not receive extra credit. So if all you did was type in the answers for this and turn that in and you didn't have a paper, I'm not even going to check to see what your score was on big ideas. I'm only going to give people extra credit who turn in this paper, and you need to have your work on it and your answer on it, just as if it was a homework assignment. Okay. And I'm going to give you time to show your work because we're going to do them together. Number 1 says write 4 2/5 as a decimal. So I'm going to turn this mixed number into a decimal, starting with the 4. The 4, which is in front of the fraction, is just going to go in front of the decimal point, which means all I really need to worry about is the 2/5. Now, I know that some of you have 2/5 memorized. Heck, you have 1/5, 2/5, 3/5, and 4/5 memorized, which if you do, you can write your answer right now. If you don't, can someone tell me how to turn a fraction into a decimal? Ashlyn? You could, that would work here. Not every fraction is you're able to do that because the bottom number doesn't always go into 100. 5 in this case does, so you could do that. What do you do when you can't get the bottom number to be 100 or a 10 or something like that? I see what you're saying, Ashlyn. Anybody? Really? We can't remember how to turn a fraction into a decimal? Maddie Intes? That's right. Top divided by bottom. Yeah, that's how you can turn any fraction into a decimal. And so 5 doesn't go into 2. So I put a decimal point and make it 20. Put a decimal point up there in my answer. How many times does 5 go into 20? 4 times. 5 times 4 is 20. So I'm finished. So 0.4 is what 2/5 is. Now there was already a 4 in front, so this is going to be 4.4. In fact, 1/5 is 2/10, 0.2. 2/5 is 4/10, 0.4. 3/5 is 6/10, 0.6. And 4/5 is 8/10 or 0.8. So if you didn't have your fifths memorized, that might be helpful. Number 2, write 13/4 as a decimal. Okay, so same thing. Do exactly what Maddie said before. Take the top number, put it inside the box. Bottom number goes outside the box. Now, what makes this division problem different from the last one? Maddie Intes. Yes, the larger number is actually inside the box. Now, we didn't do anything different. The larger number does not have to be in the box. In most cases, it's not inside the box when you're turning fractions to decimals. But because the top number always goes in the box, in this instance, the top number is bigger because this is an improper fraction. We'll always have a bigger number in the box if we have an improper fraction. How many times does 4 go into 13? 3. That's 12. Subtract, you get 1. Put your decimal point. Drop down that 0. How many times does 4 go into 10? 2 times. What is 4 times 2? 8. Subtract, and you're going to get 2. Drop down another 0. How many times does 4 go into 20? 5 times. So 3.25. Another way you could do it is by actually taking that mixed number, or taking that improper fraction and writing it as a mixed number. 4 goes into 13, we said 3 times, with 1 left over. So it's actually 3 1/4. And if you know that a 1/4 is 0.25, then you know that 3 1/4 is going to be 3.25. So that's another way you could do this one. Again, assuming you know your fourths and you have them memorized. Number 3. Now we're going to take a decimal and turn it back into a reduced fraction. Is there anything in front of the decimal? A negative sign. That's important. I don't want to get this wrong just because I didn't put a negative sign. Take the number after the decimal point, the 34, put it on top of your fraction, and then on bottom of the fraction, put its place value. Georgia, what's the place value of this 34? The hundredths column. That's right. That is how you turn a decimal into a fraction. It's pretty easy, but I do have to reduce my fractions. Can you think of a number that goes into 34 that also goes into 100? Ella? 2. Ella, how many times does 2 go into 34? That's right. And how many times does 2 go into 100? So we're going to reduce this down to -17/50. We know 2 goes in because they're both even. That's a good starting spot. That doesn't mean that if they're odd, it doesn't reduce. It just means 2 won't go in. 2 always goes into even numbers. How are we doing so far? Good. Number 4. Now we're going to order these from least to greatest on a number line. What is the number line counting by? What is it counting by? Decimals. Yeah, decimals. So they're forcing you to take these 2 fraction problems that we have down here and turn them into decimals. We can start by already taking and dragging the 2.4 up where it should go. 2.4 is obviously going to go right there. So this one's done. Now we need to take 11/5 and turn that into a decimal. And you can do that again by doing top divided by bottom, 11 divided by 5. Ashley, how many times does 5 go into 11? Okay, that's going to give us 10. We subtract and get 1. Put a decimal point. 2 of them actually. Drop down to 0. And Ashley, how many times does 5 go into 10? 2 times. That's right. So 11/5 is equal to 2.2. Now, again, an easier way to do that might have been just to turn it into a mixed number. 5 goes into 11 2 times with 1 left over. And if you know your fifths are 0.2, then that's 2.2 without doing any long division. So then that might be a shortcut you want to take if you have those fifths memorized. And if you do have your fifths memorized, you'll know that 2 3/5 is equal to 2.6. 3/5 is 6/10. That saves you some time as well. And if you don't know your fifths, I think you should memorize them. But if you don't, you would do top divided by bottom. It's always the top number inside, not the biggest number inside, but the top number. And that's going to give you 0.6. So 2.6 is going to go right there. So we're going to put the 2 3/5 right there. And so now they're arranged on the number lines. 11/5 is the smallest. 2.4 is they're in the middle, and 2 3/5 is the largest number we have in this list. Expect a problem like this with the decimal number line on your test. So you have to turn them into decimals to know where they go on the number line. Number 5. Now we're adding fractions. So I don't need to use keep change opposite because that's only something I do when I'm subtracting, but I'm adding here. Okay, so I need a common denominator still. What's the first multiple of 5 that's also a multiple of 10? 10. Yep. So that means I'm going to change the first fraction to have a denominator of 10, but I don't need to change the second fraction at all. It's going to stay 17/10. Georgia, if you're doing 5 times 2 to get 10, what's -1 times 2? -2. Good. And now that I have my common denominator, I can check to see what I'm actually going to do here. Parker Bates, am I going to go to war or joint forces? We are going to go to war. That's right. The positive or negative army won this one?
Positive.
By how many?
14.
Close. 15. Okay. Now 15/10 is not reduced. We use the smallest common denominator, and sometimes even though we use that LCD, we still have to reduce, but it's not going to be by very much. I know that some people, I still have some students that tell me they find their common denominators by multiplying the 5 and 10 together and get 50, and that works. It's just never, it usually doesn't give you the smallest one. So you'd really have to reduce there. Here we don't have to reduce by too much. What goes into 15 that also goes into 10? 5. How many times does 5 go into 15? And how many times does 5 go into 10? 2. So this is 3/2. Now I would accept that answer of 3/2 on a test. But the instructions on this question specifically say to write that as a mixed number, something I don't make you do. How many times does 2 go into 3? Once, with how many left over? Yeah. So 3/2 is the same as 1 and 1/2. And we know it's positive because, as Parker said, the positive army won this war. So we're going to write 3/2 as 1 1/2. Number 6. It's an adding problem, so I don't need to worry about rewriting this at all. I'm going to go ahead. Oh, if I'm adding, do I have to line up the decimal points? Yes. When can I ignore the decimal points? Multiplying. Not dividing, because remember, dividing, I slide them over. I still kind of need them to slide it over. But multiplying, I can completely ignore them until I'm ready to write my answer. Now, I'm going to put the 7.63 on top. Why is it important that I put the larger number on top? Huh? Well, you can't do that, right? Yeah, you can't set it up. Even though we know the answer may be negative, you still can't set it up where you're subtracting away more than what you have when you line it up vertically. You've always got to put that larger number on top. Now, if I was adding, it wouldn't make a difference. But since I know that even though it says adding, I might have to subtract, it's better just to write the larger number on top. And if we look at this one, are we going to join forces or go to war? So we're going to have to subtract anyways. So that's why I always write the larger number on top, is because sometimes, even though it says add, we end up subtracting, and then you're ready. You don't have to erase it and rewrite. Line up the decimal points. 3 minus 4, you can't do that. So we're going to borrow. We're going to make it 13 minus 4. What's that? 9. 5 minus 2. 7 minus 5. 2. Did the positive or the negative army win this battle? The negatives won. So the negatives win it by 2.39. Number 7. Sheesh, these problems. Number 7 says evaluate negative 3x plus 5y. Now, what is the x doing? What is the negative 3 doing to the x? Multiplying. And so the 5 is also multiplying to the y. When you insert these numbers in for x and y, I would suggest that you use parentheses. Because if I just write it like this, it looks an awful lot like 3 1/6, which is not what I'm supposed to get. So either put a multiplication symbol between the 3 and 1/6, or put it in parentheses. Anytime I plug a number in, I always write it in parentheses. So I like to write it like this. That shows me that I still have to multiply, and it's definitely not negative 3 to 1/6. Plus, same thing with the 5y. 5 parentheses 1/4. So this is like a 3-step problem. After I plug it in, I have to do 2 multiplication problems. And remember, when you're multiplying with fractions, you got to turn all of those improper fractions or whole numbers into, let me say that again. When you're multiplying with fractions, you have to change the mixed numbers and whole numbers into improper fractions. We can do that by putting 3/1 and 5/1. What cancels in the first multiplication problem? Maddie? Not the ones. The ones are already one. The 3 and the 6. 3 goes into itself once and 3 goes into 6 twice. So we end up with 1 times 1 on top and 1 times 2 on bottom. And if you write that, that's an easy way to get it wrong. What needs to go with the 1/2? The negative sign, yes, because it was a negative times a positive, so it's going to be negative. What cancels with the 5/1 and the 1/4? Nothing. Yeah, it doesn't. So just write 5 times 1 on top, and then on bottom 4 times 1. So now we have this addition problem. And when I'm adding fractions, a little different from multiplying fractions. Here I need a common denominator, which I don't need when I'm multiplying, but I do need when I'm adding. So what is the first multiple of 2? That's also a multiple of 4. 4. 2 times 2 is 4, and 4 times 1 is 4. So we can change these and make them out of 4. If I can give myself just a little bit more room here. The second fraction doesn't have to change at all. The top fraction, what's negative 1 times 2? Negative 1 times 2. And that's important. We don't want to lose that negative. Because if I write it as a positive, I join forces and get 7/4. If I write it as a negative, I go to war. Who wins the war? The positives by how many? By 3. Yep, so 3/4. How are we doing? Good? Okay. Number 8. Number 8 says, find -5 2/3 minus 1/6. Write your answer as a mixed number. So if it's okay with you, I know we didn't practice this a whole lot, but I'm going to leave my answer at, or leave my mixed number as a mixed number. I'm able to do that when I'm adding and subtracting. I know I can't do it when I'm multiplying, but I'm going to leave this as 5 2/3. I'm not going to change it to an improper fraction because then I just have to change it back because the silly instructions said they need a mixed number answer. Now, every rule of math still applies though. I still need a common denominator. I still have to use keep change opposite on my subtraction problems. Keep that in mind too. What is my common denominator going to be? 6. The first multiple of 3 that's also a multiple of 6 is 6. So times by 2, times by 2. Let's make this -5 4/6. Now, it's a subtraction problem. So I'm going to keep that -5 4/6. I'm going to change it to addition and then take the opposite. Keep change opposite does not mean keep change flip. What is the opposite of 1/6? -1/6. Yeah, don't flip it. This is not a division problem. Am I going to join forces or go to war? Join, they're both negative. We're going to join forces. Start with the fraction parts. What's 4/6 plus 1/6? 5/6. What's 5 plus nothing? 5. And when you join forces, do you switch teams? Not a chance. So it's -5 and 5/6. Now, if you want to do improper fractions, that's fine. You change 5 2/3 into 17/3. You times it by 2, you get -34/4. I'm sorry, over 6. Plus -1/6. That's going to give you a -35/6. That's the right answer. But because the instructions say you have to turn it to a mixed number, you'd have to convert it back into -5 and 5/6. So that's why I thought just doing it this way would save us some time. But you can do it however you want to do it. If you want to turn them into improper fractions and then convert it back, that's fine. Just know on your test on Friday, I'm not going to ask you to convert it back to a mixed number. So if you did this method and just left it as -35/6, I'd say that's perfectly fine. Your instructions aren't going to tell you to write it as a mixed number. Number 9 is a subtraction problem with decimals. That's going to be easier. I still need to use keep change opposite. Bryce, tell me what this problem would say after I convert it to an addition problem. That's right. Start with your larger number and put it on top. As we mentioned before, that's always a good habit to get into because sometimes you have to subtract even when it says add, like this one. Because you'll see they have different signs. We're going to go to war. So we're going to have to figure out how much. Oh, by the way, who wins the war? The negative. So I know my answer is negative. They win. It's just a matter of figuring out how much they win it by. So I know the negatives win. So there's my negative sign. Can't do 1 minus 6. So let's make it 11 minus 6. What's that? 5. 8 minus 7. 1. Decimal point. Make that a 10. We're going to cancel or borrow, not cancel, borrow, make that a 10. What's 10 minus 8? 2. And so we get -2.15. The negative army wins by that much. It's really important that you do the keep change opposite because what you don't want to do is join forces on a problem where you have to go to war. That's the one mistake I've had to mark off the most often on adding and subtracting problems. People will find common denominators. People will end at their decimal points. But it's when they add instead of subtract or subtract instead of add. You got to make sure you know if you're going to war or joining forces. Those are your two options when you're adding and subtracting. Number 10. Find the distance between these two numbers on a number line. 3 1/4 and negative 1 3/4. Now, anytime I'm finding the distance between two numbers, I'm going to subtract. For example, look at the number line up here. If I asked you how far 3 was away from 7, you could count 1, 2, 3, 4. What if you didn't have a number line? You do 7 minus 3, and that tells you the distance between those numbers. So I'm going to take the biggest number I got here, which is the positive 3 1/4, and I'm going to subtract it by the smallest number, the negative 1, the negative 1 3/4. That's going to tell me how far these numbers are apart. Now I'm going to use keep change opposite. And that just becomes 3 1/4 plus positive 1 3/4. And because actually it doesn't say that I have to write my answer as a mixed number, but I'm going to leave them as mixed numbers anyways. My joining forces are going to war. Joining, they're both positive, right? And so my answer is going to be positive. Let's add the fraction parts. What's 1/4 plus 3/4? 4/4. What's 3 plus 1? 4. Now I can't leave my answer as 4 4/4 because 4/4 is not reduced. What is 4/4 the same as? 1. So what's 4 plus 1? So they are 5 units apart. And I got that just by leaving them as mixed numbers and adding the fraction parts together to get 4/4, or 1, adding the whole number parts together to get 4, and 4 and 1 makes 5. Number 11. Number 11 is a keep change flip problem, but before I flip anything, we better convert them to improper fractions. Aiden? It's not working. Okay, it's just stopped working all of a sudden. Okay. All right. Well, what we'll need to do then is we'll need to write these down on our paper, and then when it is working, you could just go type those answers in. Okay. I'm not sure what's going on again, but whatever. I can't do keep change flip until I turn them into improper fractions. I don't have the choice of leaving them as mixed numbers. I have to write them because I'm multiplying, or well, dividing, probably multiplying. What's 3 1/5 as an improper fraction? 3 times 5 plus 1, 16. 16 over 5. I'm not even going to write the negative because I know one negative makes the whole answer negative. So there's my negative. I just put it in my answer. What's 4 times 1? Plus 3. Okay, so I've got 16/5 divided by 7/4. Now I can use keep change flip. So I can turn it into a multiplication problem. And unfortunately, when I flip them upside down, the 4 and 16 can't cancel anymore. Remember, you can only cancel when it's multiplication. You cannot cancel the 4 and 16 when it's still a division problem. So when you use keep change flip, it turns out the 4 and 16 don't cancel at all because they're both on top. You can only cancel a top and a bottom. So what does cancel here? Nothing. No, nothing cancels, which means nothing's going to reduce, but I still have to multiply. 16 times 4. Think of doing 4 times 10 and then 4 times 6, adding those together. 64. 40 and 24 make 64. What about 5 times 7? 35. And can I leave it like that? What does it say? Nope. It says write your answer as a mixed number, which again, I'm not a big fan of. How many times does 35 go into 64? Once, because what's 35 times 2? That's 70, isn't it? So that's too big. So it doesn't go in twice. But actually, how far away is 64 from 70? 6. So how far, what number is 6 away from 30, that second 35? 29. See what I did there? Since I know that another 6 would make it 2. 35 would go in twice. I just take 6 away from that 35 because I'm 6 away. That's going to give me 1 and 29 over 35. And remember, we said this is negative because there was one negative number. We're going to pass period 2. Period 1. You are period 2. We're going to pass period 1. Find 4.3. There's no sign in between there. What does that tell you to do? Multiply. Yep, they're squeezed together. So I'm going to think of it as if it's 43 times 26. Don't even write the decimal points. One negative number makes your answer negative. What's 6 times 3? 18, carry the 1. What's 6 times 4? 24 plus 1? Drop a 0. What's 2 times 3? 6. What's 2 times 4? Hannah, what do you get with 8 plus 0? 8. What about 5 plus 6? What about 1 plus 2 plus 8? Also 11. And then Hannah, one more question for you. I know my answer is negative, but I know it's not 1,118. How many decimal places are we supposed to have? 2. 1, 2. So make it negative 11.18. And we'll stop there for today. I don't want you guys to get too far ahead. We'll stop there. So tomorrow when you guys come in, we have what, 8 problems to finish? And then you guys can work on your chapter 2 review with any other extra time. Now, please don't make tomorrow morning the first time you're opening your chapter 2 review. Assuming Big Ideas starts working again, and it will. Make sure you guys take a look at it during your homework time today, homework time tonight when you get home. That way you can ask me questions. Remember, this isn't your homework. This is just for extra credit. Your homework is the chapter 2 review, and it's due Wednesday. And you're going to see questions just like this from your chapter in the chapter 2 review. So if you get stuck on something, you can either look in your notes, you can look here, or you can come ask me if you really can't figure it out. Yeah.